All right, we're going to take a look at Aleks 10.3, number 7. This is Aleks 10.3, number 7. It says this: arithmetic and geometric sequences, identifying and writing explicit rule. The sequence below are either arithmetic or sequences or geometric sequences. For each sequence, determine whether it is arithmetic or geometric and write the formula for the nth term, an of that sequence. And so just before we begin here, let me just remind you where these formulas come from. If you go to your PowerSchool Learning site, on the home page, you will have, come on now, let's see it load in. Under Digital Resources, the formula chart is the second box down. You can click there. Or if you're in Google Classroom, and you go to Classwork, it's right in the daily, weekly links. It's the fourth link down right there. Both of them will pull up your formula chart. The arithmetic and geometric I have here highlighted. There are these two. So I'll write it down over here now. The arithmetic formula. The arithmetic formula is a sub n equals a1 plus n minus 1 times the common difference. And again, these ones correspond to one another and the n's correspond to one another. And I'll go over that in a second. And geometric, the geometric formula is that an equals a1 times the r to the power of n minus 1, where again the ones correspond and the n's correspond. That formula is from right there. So how you determine if something's arithmetic or geometric, as you see, if it's arithmetic, you should either be adding the same number each time or subtracting the same number each time. If it's geometric, you'll be multiplying or dividing. So there's a way to check, and the formula was this: if you take the second term and for arithmetic subtract the first term, you should get the same value as if you took the third term and subtract the second. So the way in formula form is the common difference means you take any term if you subtract the one before it. That's your value. And for the common ratio, it's you take any term and you divide the one that comes before it. So if we checked here to see if the part A was arithmetic, you would say, okay, what is 16 minus 8? And our answer there is 8. And what you would want to check is to see if 32 minus 16. So I first did second term minus first term. I got 8. Now I'm doing third term minus second term. This is 16. Since they do not match up, it's not arithmetic. This one's going to have to be geometric. Let's go ahead and check to make sure. So if I'm checking to make sure, if I take the second term and divide it by the first term, I get 2. Now this should match if I take the third term and divide it by the second term. Once again, I get 2. Since they are the same number, this is geometric. So for number 1, I could plug in my values to get the formula. This right here is the r. That is our r. So I could say a sub n is going to equal a1, which is an 8, times r, which we got here is 2, to the power of n minus 1. That is our function. That would be the answer right there, 8 times 2 to the power of n minus 1. Now, what you could also do, which should still be accurate, I'm not sure how Aleks would like this, but you don't have to use the first term. This formula is mathematically going to give you the same values as if you put in the second term, as root 2 of n minus 2. So mathematically, this should be exactly the same as well. Just because the term number and that 1 correspond. So you don't have to put the first term in. You could use the second. I could use the third if I wanted to. And mathematically, they're all the same. Now, once again, I'm not sure how Aleks would like it. Sometimes it's pretty sensitive. But technically speaking, if you went to like Desmos, and made a table out of all these, you'd see the values are exactly the same. That would produce the same thing. So that's the geometric part. And I can show you that at the end of the video, but I'm going to move on to the next one. Let's check to see if part B is arithmetic or geometric. So I would start first by taking the second term and subtracting the first. And on that one, I get 2. So I check it. I'm going to take the third term and minus the second. Once again, I get 2. Since these match up, it's going to be arithmetic, which means it's not going to be geometric. Let's try it. Here you would take your second term and divide the first, which that does not reduce. And then you take the third term and divide the second. You see these are not equal to one another. 13 is not 15, 11 is not 13. Those are not equal. So it's not geometric, it's arithmetic. So in this one we would use the arithmetic formula. Let's see here, how can I click extend page? So now I'm going to take this formula and we'll solve it for the part B. So I can say AN equals, I'll plug in the 11 plus N minus 1 times the common difference, which we just got up here as being 2. Now this one I can actually simplify. This one I could not simplify these because of PEMDAS, order of operations, PEMDAS. I could not simplify those because you can't multiply without doing a power first. So because of that, I had to leave it. This one I can simplify. I can multiply this through. I'm going to distribute that. And so this would be equal to 11 plus 2n. And then minus 1 times 2 is a negative 2. And I can reduce that one more time. 11 minus 2 is 9. So I can say 9 plus 2n is my an. That would be your formula there. 9 plus 2n. And that would be your solution. Again, on this one, you don't have to use your first term. You could use the second term. Plug a 13 there, but it'd be n minus 2 if you did that. Or you could plug in the third term, put a 15 there, n minus 3. And mathematically, you should end up with the same answer each time. So I told you I would show you by graph. These would be the same. I'm just going to type them as y equals to make sure the table works. I'm not sure if the table will work or cooperate with me if I don't use the values y and x. So that's what I'm doing here. So the power of x minus 1. And I'm going to copy this. Whoops, I meant to copy it. Well, I guess I'll have to type it in again. A lot of things are not cooperating with me. Okay, 9x minus 1. There's my formula that I was trying to type in a second ago. And then the second one is y equals 16 times 2 to the power of x minus 2. And this time I'm going to copy first. Copy. My last one was going to be this one here, 32 to the power of x minus 3. And I'll change the color. And you can see by table, and you can also see by graphs. These are all the same graphs. The tables match, the pictures match. All three of these are the same, even though the numbers are different. And that was just to show you, you don't have to have the first term necessarily. You could put in the second term or the third term and just know this one corresponds with this one. So